So today we're going to be looking at simplifying radicals and exponential expressions with radical bases. So just as a review, when we're getting something into its simplest radical form, we're going to use the prime factorization. So over here we're just going to prime factor our 96. I usually start out with 2 times something if I know it's an even number, because I know those is easier. So 2 times 48. And then I look and I say, well, that is 8 times 6, 4 times 2, 2 times 2, and 2 times 3. So now I've got to be careful to make sure I get all these factors. So I've got a 2, 2, 2, 2, 2, and a 3. So if I write that all out, this is the same as the square root of 2 times 2 times 2 times 2 times 2 times 3, because I have 1, 2, 3, 4, 5 2's and 1 3. Now remember, whenever we're trying to take the square root of something, 2 times 2 is 2 squared, and the square root of 2 squared is just 2. So basically, anytime we have a pair of underneath the radical sign, so one pair, 1 comes out, another pair, 1 comes out, and we're left with 2 times 3 still under the radical. So I've got 2 times 2, and then underneath 2 times 3 is 6, and to simplify that even further would be 4 times the square root of 6. So right there is the simplest radical form. Now if we want to use a table, now just keep in mind when we've got these 1/2 exponents or fractional exponents, let's just remember that if we have x to the 1/2, that is equal to the square root of x. If we have x to the 1/3, that's equal to the cube root of x. So anytime, this is called the index number, whatever's on in the denominator of the fraction, then that's the index. And we like to get them a lot of times so there's a 1 on top. So if we have x to the 1/7, that would be the 7th root of x. So keep that in mind as we're going through these problems here. So now we've got f of x is 4 to the x, and g of x is 4 to the 1/2 x. And we're trying to find a, b, and c of these missing values. Well, let's first take a look at these f of x. All we're doing is we're substituting the x value in for x up here. So this is 4 to the -2, which is equal to 1 over 4 squared, which is equal to 1/16. 4 to the -1 is 1 over 4 to the first, which is 1/4. 4 to the 0, well, anything to the 0 power equals 1. 4 to the first, we know that's 4, and 4 squared, we know that's 16. So let's do the same thing with our g of x now. So g of x, we're going to do the same thing. We're going to take 4, and I'm going to do it down here so I have a little bit more room. 4 to the 1/2 times a -2. Well, 1/2 times -2 is equal to 4 to the -1. And we know that if it's a negative exponent, we do 1 over 4. So this is 1/4. So our a value would be 1/4 up here. Same thing here. Let's do the next one. 4 to the 1/2 times a -1. So this would equal 4 to the -1/2. Sorry, I wrote that a little bit. So we have 1 over 4 to the 1/2. Well, 4 to the 1/2 is the same as 1 over the square root of 4, which is equal to 1/2. And that's where we get this 1/2 right here. B, 4 to the 1/2 times 0. Well, that's still equal to 4 to the 0, so that's 1. So our B value is 1 here. They've done 4 to the 1/2 times 1 is equal to 4 to the 1/2. Well, we know that's the same thing as the square root of 4, which is equal to 2. So we've got that. And then finally, we've got 4 to the 1/2 times 2, which equals 4 to the 1/2 times 2 is 1, which is equal to just 4. And there's our c values right there. And you'll notice that each of these values is each of our g of x values, the 1/2 are the square root of the f of x values. Okay, so now we're going to just simplify this expression, 48 to the 1/2. Well, there's a couple ways I can do it. First way is I'm just going to make that half into a radical, because we know that 1/2 is equal to the square root of 48. And I'm going to simplify that into, I know that's 16 times 3. Now you could prime factor 48 and break it down, but any way you do it, you're still going to get the same thing. So this is square root of 16 times the square root of 3. Well, I know the square root of 16 is equal to 4, and I'm left with the square root of 3. Now over here I notice I only have halves. I don't have any square roots. Well, I know that 3 can be written as 3 to the 1/2 power. So that would be this answer right here. Another way you could do this is if we look at 48 to the 1/2, we could do the same thing and still factor this. 16 times 3, well, that's 16 to the 1/2 times 3 to the 1/2. And that's the square root of 16, which is 16 to the 1/2, which equals to 4 times 3 to the 1/2. And you're going to get the same answer. Finally, let's look at this. There's a couple of examples where we've got a lot going on here. So let's look at this right here. We've got, remember that f of x equals a times b to the x. This right here is our initial value. So the initial value is what is not being carried to an exponential value. So in this case, we've got a 7 right here that's outside of this parenthesis where the exponent is. So our initial value is 7. Once we've got that initial value down, then we don't need to worry about 7 anymore. 7's taken care of. Now we're just going to focus on what's in the parenthesis here. So in order to do this, we're going to factor 54, which is 2 times 27, and that's 3 times 9, and 9 is 3 times 3. Now keep in mind this is a cube root that we're looking at, so we're looking at groups of 3. So the cube root of 54 is the same thing as the cube root of 2 times 3 times 3 times 3. And if I look, I've got one set of 3, so that comes out. And then left underneath is the cube root of 2. So if you notice, the simplified base for the function, we're given the cube root of 2 part. The part we're missing is the 3. Again, we're not worrying about the 7 because that's the initial value. This is the base, is what's taken to the exponential power. The domain of the function is going to be all real numbers. That's a symbol for all real numbers because you can put any number in for x and get this. The range of the function is going to be for those y such that y is greater than 0. That's the range. Okay, one more like that. One of the things I like to do on this is if we look at this function right here, notice it's a 2x over 3. I like to split that up so I have a 1 on top of a denominator without an x. So I'm going to rewrite this as 1/2 times 27 to the 1/3, all of that to the 2x. Because when we do products of powers, 2x times 1/3 is equal to 2x over 3. And I'm just going to split it up so it's easier for me to see. Again, the initial value, we're looking for the very beginning value. Here's 1/2. So the initial value is 1/2. Once we've got that 1/2, we can just focus on what the base is going to be here. The simplified base. So 27 to the 1/3, all of that to the 2x. Well, this is the same thing as the cube root of 27. I know the cube root of 27 is equal to 3, because 3 times 3 times 3 equals 9. So I've got 3 to the 2x. Well, when we simplify this, we can rewrite this as 3 squared to the x, because remember, a power to the power means we multiply. We know 3 squared equals 9, so 9 to the x is our simplified base. And then the domain, again, is going to be all of our real numbers, and the range is going to be the y value such that y is greater than 0.